Hi fellas, here's question 14 of your practice exam, which I couldn't post in the normal way on StudyWiz. So consider the function fx equals x squared plus 5x minus 6 all over x minus 1. Our first job here is to simply replace the 1 with, replace the x's in the function with the number 1. Couldn't be easier than that. So for part A, we would say f1 is equal to 1 squared plus 5 lots of 1 minus 6 over 1 minus 1. And that will come to 0 over 0. Now we're required to comment on the result. We can say the result is not defined. In mathematics, 0 over 0 has no real meaning. Now part B is asking us, for what value of x is the function discontinuous? Well, that's quite simply where the denominator is equal to 0, where that is equal to 0. And so really that's all we've got to say. We say that fx is discontinuous when x minus 1 equals 0. In other words, when x is equal to 1. Now, so you can see why that is the case, can't you? When x is equal to 1, we have something or other, whatever it is up there. In fact, we found out from part A it was 0. Anyway, the fact is, down here, when x is 1, our denominator will equal 0, and that will produce a discontinuity. Okay, so part C is now asking us to factorise the numerator of the function and simplify the function. So here we go. I've rewritten it here, and you can see what's going on. We're going to use the product sum number method. The product is the coefficient of x squared, which is 1, times the constant term, which is negative 6. So 1 times negative 6 is negative 6. The sum is quite simply the coefficient of the middle term, and the numbers we require, two numbers such that the product is negative 6, and when added give you negative 5. So that times that equals that, and that plus that quite clearly equals that. So our function, we can say, equals x plus 6 brackets x minus 1 all over x minus 1. And you can see that the x minus 1s are common to top and bottom, so they are just going to cancel out. Okay, so that means our function can be simplified to quite simply just x plus 6. But we do have to note that x cannot equal 1. And it cannot equal 1 for the reasons we saw in the previous section. The denominator equals 0 in the unsimplified version of the function. Okay, part D. Now part D is asking us to evaluate this limit here if it exists. Well, our function, now that it's simplified, is in such a form that we can solve that by direct substitution. So part D goes like this. The limit as x approaches 1 of our function is simply equal to 1 plus 6, which equals 7. Okay? Now our final job is to sketch the graph. Well, it turns out, of course, that because the function simplifies effectively to fx equals x plus 6, there's just a straight line graph that you can see here, a bit rough and ready. Now the thing is, there is a significant point, as it were, when x is equal to 1. Remember what we're talking about there? As x approaches 1, what we're saying is the function value approaches 7. Right, so 7's across there, but it doesn't actually reach it because the function is discontinuous when x is equal to 1. So notice how we indicate that on the graph. It's an open circle, and there should be nothing inside it, and the function x plus 6 continues either side of it. So our complicated function there is for all intents and purposes the same as the function x plus 6, but we do have that discontinuity there. And that's how you do question 14, lads. Good luck.